Okay, so we have gone over our basic percents, how to get them, how to write them. We've also gone over how to use a percent box. If you are watching this video and you have done neither, you may want to go back and watch those first. We're going to move on to percents embedded in word problems and how we work with them, how we get the numbers out, how we set them up so that we can organize our thinking and easily solve the problem. At the beginning, of course, it shows you again your percent box. All we have to remember here is that we are going to label with part over total. We go to that first just because we have that ingrained in our memory with fractions since third grade, fourth grade. We've always thought part over total. If you look at a problem and you cannot figure out the part over total, our new words that we're going to focus on for percents is over of. So is would be the same thing as part, and of is the same thing as total. We're just going to go over a couple of problems to look at a variety of information. So I'm going to skip down to Jacob. It says Jacob often takes his dad out to lunch. His favorite number is 30, so he always leaves a $30 tip. Okay, so favorite number is 30, always leaves a $30 tip. On Monday, he took his dad out to lunch and the total bill was $150. What percent of the $150 bill was his $30 tip? Okay, so let's set up our percent box. And organize our numbers. What I am ultimately looking for was we're looking for our percent of the $150 bill. So I'm going to label part over total, or is over of. Let's start with what we know. He took his dad out to lunch and the total bill was $150. We're looking for what percent of the $150 was his $30 tip. We have to think, if you're thinking about a fraction, what would be your part over total? My part would be the $30 tip. My total would be the bill of $150. I am looking for what percent. So I don't know my percent, but I do know a percent is always, always, always out of 100. So I'm looking at my numbers and I'm thinking, okay, I've got the 150 and 100 completely filled out. How do I get from one to the other? I can't. So I need to reduce. Let's make reduction easy. Let's get rid of the 0. As long as I have one on the top and the bottom, I can get rid of those, so it would make our number a little bit more manageable. Now I have 3 over 15. Now I can easily see what number they both share. 3 and 15 both share a 3, so I'm going to divide 3 by 3. I get 1. 15 by 3 is 5. So my base is 1/5. Now, can I get from 5 to 100? Yes, 5 times 20 is 100. Whatever I do to the bottom, I have to do to the top. So 1 times 20 equals x, which means x equals 20. Now remember, I was looking for what percent. That means my answer is 20%, meaning if he paid $30 for a tip means something you give extra to your waiter or waitress. If you think that they did a great job, you're going to give a tip, and it's going to be based on their service usually. So if it was $150 and he paid $30 extra in tip to say good job, what he actually gave was 20% more than his bill originally was. But they give us a second question with the same scenario. That was Monday. Now on Friday, he takes his mom out for Mother's Day. The total dinner bill was $300. What percent of 300 was his $30 tip? Okay, because remember we're doing $30 tips. Why? Because he likes the number 30. Okay, so I'm going to have to do a percent box. And I want to make sure I label. I'm going to put my labels out here a little bit in case I have to reduce. Part or is over total or of. I'm again looking for a percent. So what do we know? Can we figure out the part over total? Well, yeah. His part over total, his part was $30 tip. His total bill was $300 in this case. We're looking for what percent, so we don't know the percent, but what do we know about percents? They're always out of 100. So no, I cannot get from 300 to 100. I could go back the other way, but let's go ahead and practice the reduction real quick. I'm going to try to reduce 30 over 300, and the easy thing here is look at these zeros. Let's get rid of 1 on the top, 1 on the bottom. That leaves me with 3 over 30. Well, that should be easy to figure out. 3 and 30 both share a 3, so divide by 3. 3 divided by 3 is 1. 30 divided by 3 is 10. So my reduced fraction is 1/10. Now I can easily go from 10 to 100, it's times 10. Whatever I do to the bottom, I have to do to the top. So 1 times 10 gives us x, and x equals 10%. So when he took his dad out, it was a 20% tip. When he took mom out, he only gave a 10% tip. Okay, let's look at another one. At first, when we see a table, we're kind of looking for, is there a rule? Is there some sort of sequence we're looking for? But this table just is for informational purposes. The Sweet Treat Candy Shop is surveying middle school students to determine which jelly bean flavor is the most popular. So far, they have surveyed 250 students. The chart below shows the results. So out of 250 students, 92 like cherry, 66 lemon lime, 29 grape, 35 bubblegum, 28 orange. What percent of students prefer bubblegum jelly beans? Okay, let's go ahead and set up our percent box. This one gives us lots of room. And of course, my favorite word, label. Part or is over total or of. Okay, so what do I know? Do I know a part over total? Well, remember, they asked specifically for bubble gum. So bubble gum, I have my part bubble gum. That's going to be 35. Do I know my total? Yes, it's all of these together. It's 250. I'm looking for what percent. So I don't know what percent, but what do I know about a percent? It's always out of 100. So I'm going to look at, is there a way to get from 250 to 100? No. So I'm going to go ahead and reduce. I've got 35 and 250. So I'm thinking, what would go into both? Well, I see a 5 and a 0. And I know my divisibility rules. If I have a 5 and a 0, I know that 5 goes into both. So 35 divided by 5 is 7. 250, well, 25 divided by 5 is 5, and then your 0, so you can reduce to 7/50ths. Now can I get from 50 to 100? Absolutely, it's times 2. Whatever I do to the bottom, I also do to the top. 7 times 2 is x, which means x equals 14. Go back and let's see what we were looking for. What percent? So that means that 14 is a percent. So 14% liked bubble gum. And we could actually go back and use this to find the percent that likes cherry, the percent that likes lemon lime. We would have to just change our numbers around. Okay, why don't you try one? Let's go to this. The new amusement park is opening next year. The students of Cy-Fair ISD will get to vote for the new park's name. The results for the 1,200 students who have voted so far are shown in the circle graph below. How many students voted for Frankie's Funland? Okay, so let me give you some information before you try on your own. We do know that there were 1,200 students who voted. We also know from our pie graph, which we can't read very well, it's very dark, but it does give us information here. They specifically want to know how many students voted for Frankie's Funland. They give us a little bit of a key here. Frankie's Funland is 45%. Okay, so take that information, pause your video, set up your percent box, labels, numbers, try to get your answer, and come on back and check with me. Okay, so you should have tried this one on your own. First, we need to set up a percent box. I am looking for the number of students who voted for Frankie's Funland. I'm going to label with part or is over total or of. I do know my part over total is, well, I don't know my part, but I do know my total because they asked, or not asked, but they had 1,200 students vote so far. What I'm looking for is the number of students who voted for Frankie's Funland. Well, that's my part. So I must somewhere have my percent. Well, let's look in our box here. It says Frankie's Funland, 45%. How do we write a percent? 45, always over 100. Can I get from 1,200 to 100? No. I could go backwards, but let's go ahead and reduce so our scale factor is a little bit smaller. So I have my 45 and my 100 complete, so I'm going to reduce that, 45 and 100. Okay, we've got our 5 again and our 0 again. So divisibility rules tells us those both can be divided by 5. So 45 divided by 5 is 9. 100 divided by 5 is 20. So there is my base, or my reduced. So I'm going to look at how do I get from 20 to 1,200. That's going to be times 60. So that means that 9 times 60 gives me x. So 9 times 60, x equals 540. And what was our question asking us? How many students voted? So it's going to be 540 students voted for Frankie's Funland. Okay, let's try another one. Miss Patty bought a pair of shoes that usually sell for $60. She bought the shoes on sale for $25% off. How much money did she pay for the shoes? Okay, well, let's start off and do a percent box after, of course, I get the information. Pair of shoes that usually sell for $60. She bought the shoes on sale 25% off How much money did she pay for the shoes? Okay, so go ahead and pause the video. I want you to do a percent box, label, put your numbers, find your scale factor, and see if you can come up with your answer. Okay, so you should have paused the video. No cheating. Set it up. Label, of course, everything. Part or is over total or of. And what do we know? I know the shoes usually cost $60. So would that be part or total? 60 would be total. She bought the shoes on sale for 25% off. Well, I know my percent, 25, is always out of 100. How much money did she pay for the shoes? I'm looking for X. So my question would be, can I get from 60 to 100 or 100 to 60? No. So let's go ahead and reduce. Here's where I have all of my information, 25 and 100, and those are easy. Think of money. I know that 25 divides into 25 one time. 25 goes into 100 4 times. So here is my reduced fraction. Now, can I get from 4 to 60? Yes, 4 times 15 is 60. So 1 times 15 gives me X. X equals 15. Okay, so you have to think, is that my answer? Well, let's look back at our question. How much money did she pay for the shoes? So she only paid $15? No, that doesn't seem right. Let's go back and look at our information. Her shoes were normally $60. She got 25% off. So the 15 is how much money they took off of 60. But I'm looking for how much money did she pay. She paid, well, we have to figure that out. We have 60. They took $15 off. She paid $45 for the shoes on sale. Okay, last one. We're going to try this on our own, and this is kind of a fun one. You can kind of see what your teachers do. No, we really kind of have cheat sheets to do this. We don't have to do all this work every time. But let's say you don't have your cheat sheet with you and you're trying to think, okay, I'm grading these papers for my students and I don't know how much each of them are worth. So let's figure it out. There were 20 questions on the 7th grade semester exam. Shannon missed 3 problems. What grade did she receive? Okay, so let's highlight our information. We've got 20 questions. She missed 3 problems. We're looking for the grade she received. Why don't you pause the video, use your percent box, labels, put your numbers in, see if you can figure this one out on your own. Okay, so you should have at least attempted this on your own. Let's set it up. Percent box. Did I mention you should label? I think I did. Part or is over total or of. So what do we know? 20 questions, missed 3. Well, there's my part of over total. The part missed is 3. Total is 20. What grade did she receive? Well, grades are done in percent. So they're basically saying, what percent did she receive? We don't know what percent, but what do we know about percents? They're always out of 100. So now I need to decide, can I get from 20 to 100? Yes, 20 times 5 gives you 100. So 3 times 5 is X. So X equals 15. So that means we're going to mark 15 points off of the total. So her grade would be 100 minus 15. Well, 100 minus 15 is 85. We also could have done that where if you know she missed 3 out of 20 questions, let me show you a different way, and you may have done this. Proportion box, label, part, total is of. I could have done, instead of how many she missed, I could have thought, okay, well, how many did she get right? Well, if there are 20 total questions, she missed 3, that means she got 17 right. We're looking for the percent of her grade. So go back and do your scale factor. 20 times 5 is 100. 17 times 5 gives you X. Well, 17 times 5, X equals 85. So either way, you could have set it up, and either way would have given you the correct answer. This one, you just have to, you're given how many points off, and you have to figure out the grade. This one gives you the grade. So it's kind of whichever one is easier for you.